In today's video, we are going to represent and graph ratios. Evidence-wise, we're going to first have to be able to write ratios. We're then going to have to create equivalent ratios to fill out our tables, because we're going to need those in order to actually graph a ratio. Our learning experience, we're going to have a longer example than one you do. We'll look at the things to remember, and then there's just one suggested practice problem. So a little bit of a shorter video today, which is always nice.
Nice.
So let's jump right into it. For our one and only example, we are going to graph the ratio 2 to 3. Then we're going to figure out if x is 10, what would y be? So there are a few things that we need to do here. First off, we need to find our ratio. Now, very nicely, our ratio is already written for us here, 2 to 3. So we're going to put it into our ratio table, 2 to 3. We're also going to say that x is 2 and y is 3. That'll help us when we get to graphing it. As for finding our equivalent ratios, I'm not going to spend too long explaining how to do this. If you need to double check how to do it, you can always watch the previous video in which we go over finding / making equivalent ratio tables. Basically, we multiply by 2, then by 3, then by 4. We get 4, and then 6, and then 8. Here, we do the exact same thing. Whatever we do to one side, we have to do to the other side. So 2 times 3 is 6, 3 times 3 is 9, 3 times 4 is 12. Really, when you look at it, it's just multiples of 2 and 3. You just have to make sure that they are lined up with the correct multiple. And that's it. So, pause the video if you need to catch up with us for a sec. But otherwise, we're just going to continue right on. The next thing to do would be to make yourself a coordinate plane. We already have one here. You can sketch it out and pause the video again if you need to. I would suggest doing this on graph paper if you have some. Now, this is all labeled. We already have x and y labeled here. We have our scale, which is nice. So all we have to do is we have to plot our points. So our first point was this one here. So we're going to go over to x is 2, and then up to y is 3. Amazing. This should all be review. The next one is going to be 4 and 6. So we're going to go to 4. Then we're going to go up to 6. The next one is going to be at 6 and 9. So we're going to go up to 6. And then all the way up to 9. And before we plot the last one, I just want to point out one thing. Our original ratio, you'll remember, was 2 to 3. If we look at our x direction, every point is a distance of 2 from the previous one. That means without even looking at what our last ratio should be, we should know that it should be over by 2. Our y value was 3, and if we look here, we go up 3 spots. We go up here 3 as well. So that means that our next value should be going up by 3 again, which means that our next point, if we hadn't already calculated it, should be 8 and 12. And if we look over here underneath the blue scribbles that I just made, we can see it is indeed 8 and 12. You can also extend this back the other direction. If we go down 3 and then over 2, you'll see that we end up back here at 0, 0. That's actually what we should expect when we're graphing a ratio. You should always have a point right at the origin. The last part of this that we need to do is just connect all of our points. So, in an ideal world, you'll do this in as straight of a line as possible. I know that my line isn't going to be perfectly straight because I'm drawing on a computer and I don't have a straight edge. but we can keep going, and it should continue like that. We can, of course, put an arrow on the end. You could put an arrow on this end as well, but for right now, we're not going to deal with negative ratios, so it's okay if you leave it like this. So, pause the video again if you need to add anything that we haven't written down yet. The final part of our question was, if x is 10, what would y be? And to find that, once I find a slightly different color to use, sure, is that more of a pink? Yeah. Is going to just be that. If x is 10, well, x would be over here. What would y be? So all we have to do is we have to draw a line up from 10 until we hit our line for our graph, and then we're going to go over to the y-axis, and we'll see that we hit 15. That means if x is 10, y will be 15. And that's the final part of this that we need to figure out. Nothing too bad. You can again look for a pattern. We went over 2 and then up 3, so it still follows that pattern. We know that we're 100% right that way. You could also just extend the ratio table if you wanted to, but graphing makes it a lot easier. You only need to find like 1 or 2 equivalent ratios to make a line, and then you can use it to find pretty much anything else you need. You can even use it to find things that you wouldn't be able to normally multiply by. Again, this is going to start getting real messy real fast. But if we wanted to find what y would be if x was 7, we could start at 7. We could go up, and that crosses about there. So that would be about here. So if x was 7, y would be like 10 and a third or so. So, kind of cool. Pause the video, write all of this down. This is the only example that we're doing today, and it had quite a few parts to it. For our you-do problem, in Minecraft, you need 6 wooden planks to make 4 wooden stairs. The first thing that you're going to do is graph the ratio, and then after you graph it, you are going to figure out how many planks you would need to make 32 wooden stairs. So again, you're graphing the ratio, then figuring out how many planks you would need to make 32 wooden stairs. Things to remember from this video: you must make a table for your ratio. It's going to be almost impossible. Once you start connecting what we just did, you might be able to do it without a ratio table, but make a ratio table to help you graph it. You're going to plot the ratios you find in your table on your coordinate plane, and then you can use that coordinate plane to help you find other values. It's really, really handy. It's really, really cool. Eventually, you can use it to compare two ratios as well. We're not going to worry about that, though. That is for another day. So our suggested practice problem for today: you have a fast food restaurant that has a deal of 4 burgers for $3. You're going to do 4 things, which is why I only gave you one suggested practice problem today. You're going to create a ratio to describe burgers to the total cost. Secondly, you're going to make a ratio table for your ratio. Make like 2 or 3 equivalent ratios in there. You're going to graph your ratio on a coordinate plane. You'll have to make your own coordinate plane. To be fair, you could probably use the same one from the mini lesson, but it'd look a little bit messy. And then finally, using your graph, you're going to find the cost of 10 burgers. That was not going to be as easy, and the cost is not going to be a whole number. You're going to have some change left over. So give it a shot. Good luck. Oh, that was a pretty good video, I think. Don't have to do anything else.